we will have one server. Say for example, I have a server called as dev. On this server, I have a database called as D1. I have another database called as D2. I have an ASM to store my data files or all the files which are related to the database. So let me make ASM. I'm making it as ASM disk groups. Just think that this is ASM disk groups. Now, for these two databases, we need to have two instances. So I'll have an instance associated with the database D1, and I'll also have an instance associated with the database D2. And this is the ASM instance. So this is the type of configuration we saw till now, which is a standalone. That means for each and every database we have one instance. Okay, the standalone configuration is nothing but for each and every database we will have one instance. An instance is nothing but SGA plus background process. Now, can you guys think of like, will we have any problem with this kind of configurations? Just think in generic, will we have any problems with this kind of setup? Say for example, this server is located in Texas. Can you guess any problems associated with this kind of setup? What kind of failures you're talking about? Yeah, what? You're talking about the natural calamities? Okay, yeah, that is one of the problem. Say for example, this server is in Texas, so if I have any natural calamities like hurricane, then my data center will go down. That means all the databases which are present on this server will go down. So we'll not have the database available for the users. As a result, the end applications will be down and your website will also be down. So what is the alternative, or what is the alternative configuration in order to withstand natural calamities? So what is the alternative configuration we saw to withstand from natural calamities? DG, data card, yes. So we created another server and we hosted the server in a different data center. Say for example, we located this server in California and my server name is devdr. And we created three databases on this server, which is D1, R, D2R, and D3R. And we have the same setup. Whatever we set up in Texas, we do have the same setup on California. Now if something goes wrong in Texas, we'll make this server up and running, or else we'll fail over the data guard configuration in such a way that the California server will be switched to the primary. So all the users will be redirected to the California server and they will be able to perform their input-output operations. Now, but during the failover, do we require some downtime or not? Do we require some downtime to perform the failover or not? How much time do you think of? It will not take 30 minutes. Probably it may take 10 to 15 minutes of time to fail over the server, to fail over dev.dr as primary. So we do require 15 minutes of downtime. But if the production service needs to be up and running 24/7, so even 15 minutes outage will cause a lot of business loss. So Oracle came up with an alternative structure to provide high availability. Of course, to withstand the natural calamities, we do require a data guard because if something goes wrong in the data center itself, we will have the another server to make up and running such that the users will be started connecting to the California server and they can perform their operations. But say for example, that is for the natural calamities, we have the data guard. To withstand the natural calamities, we have the data guard, and probably with 15 minutes of lag or 15 minutes of downtime, we can make the server available to the users to perform their input operations. But now, uh, if something happens to this server, think this is a physical server which is hosted in Texas data center, and now due to some failure on the server, this whole server, the server dev is down. Probably because of some corrupted disks or probably because of memory failure or probably because of processor failure, this server is down. In that case also, we do require 15 minutes of downtime in order to make dev.dr up and running. Okay, forget about the natural calamities. If there are natural calamities, yes, we do require the data guard to fail over the dev.dr as a primary. But now what I'm saying is like uh, due to some power failure or due to some CPU failure or memory failure, this server is down. Now we do require 15 minutes of downtime in order to make this server as a primary. So in order to in order to overcome this 15 minutes of downtime without any downtime, to provide high availability, Oracle came up with an alternative configuration. That is nothing but rack, which stands for real application clusters. Which stands for real application cluster. So in real application cluster, the configuration will be like this. Instead of having a server dev and a database associated with one instance, let me know if you're unable to hear me or if you have any. So here I have a standalone setup where each and every database is associated with one instance. That is nothing but a standalone. But in real application clusters, what we'll do is like we will have the shared storage or the storage, and this storage can be shared across two servers. Okay, so there are some set of disks on this storage part. Say for example I have 6 disks, 1, 2, 3, 4, 5 and 6. I have 6 disks which can be shared across two servers. Okay, so say for example I have a server called as dev1. I have another server called as dev2. The entire setup, dev1 and dev2 servers along with the shared storage is present in Texas data center. Okay, now we will have a database. Database is nothing but collection of physical files. So what are the physical files related to the database? Data files, redo log files, control file, archive log files, and SP file. So these are the physical files of any database. All these physical files will be sitting on the shared storage. That means we'll have the database created on this shared storage. So say for example the database which I created is called as dev, which is present on this shared storage. Shared storage you can think of like having a network. For example, you're in an apartment, your friend has a laptop and you have a laptop. Now if you want to have some files shared across both of you, you can copy the pictures into shared folder and you can share it across the network. That means all the users who are connected to that network can access those pictures. In a similar way, even here the dev1 and dev2 both will be present in the same network, and we'll attach a disk to the router such that it will be shared across dev1 and dev2. So whatever will store it in shared storage, the same thing appears on dev1 as well as on dev2. It is similar to the pictures you copy into the shared folder. Okay. Now we'll create a database called as dev on this shared storage, which can be accessed by server dev1 and dev2, and an instance will be running on dev1. Instance is nothing but the SGA plus background process. So let me make this as SGA. And background process. So that means instead of having one instance associated with one database, we will have two instances associated with one database. There is no limitation that you just need to have two instances or two servers. You can have a number of instances of server. So each and every server in the rack cluster are called as an instance. Is called as a node. So right now I have two nodes. Okay. node 1 and node 2. Node 1 is dev 1 and node 2 is dev 2. These two are physically independent servers, but they are connected to each other over the network. Okay, so dev 1 and dev 2 are two physical independent servers which are connected over the network. So let me make this as a network, and let me name this network as Ethernet 1. Because using Ethernet 1 interface, these two servers will be communicating with each other. Okay. Now, so these two servers are physically independent, which are connected over the network, and both the servers can access this shared storage. Now, if something happens to the server dev 1, some power failure or some CPU failure or memory failure, still we will have dev 2 which will access the shared storage. So that means if some of the users are connected to dev 1 server, and at that time, say for example, there are 15 users connected to dev 1. There are 15 users who are connected to dev 1, and there are 20 users, or say for example 16 users connected to dev 2. At this moment of time, if something happens to the dev 1 server, and if the dev 1 server goes down, now we'll have the dev 2 server which can still accept the request from the user, which can perform or which can serve the requests which are coming from the users. So who are the 15 users who connected to dev 1 will be routed to dev 2. If dev 1 goes down, automatically all the sessions who are connected to all the users who are connected to dev 1 will be failed over to dev 2. User will not even know that dev 1 went down. From the user perspective, the whole setup is one physical server. They think that they connected to the database, that's it. If something goes wrong on dev 1, all the sessions or all the users who are connected to dev 1 will be routed onto dev 2. So this is one of the advantage of real application clusters. It provides high availability. But how? How these two databases can access the same disks? So say for example, there are 16 users here and 15 users here. Now this one of the user among the 16 is accessing EMP table, or say for example he is updating EMP table. So he is updating EMP table. In EMP table, he probably updating 100 rows. Okay. Whenever you update the rows, where the modified data will be present, whether it will be present in SGA or whether it will be present in the physical storage.
SGA.
Okay, so whenever the user is trying to update the 100 rows, first the server process will pick the data from the physical storage, it will put it into the buffer cache, and it will update the blocks in the buffer cache. Then depending upon the read log switch or depending upon when the checkpoint is issued, it will trigger the DBWR to write the dirty buffers from buffer cache to data files, or else if there are no free buffers available in the buffer cache. Now at this moment of time, at 9:30, one of the user updated 100 rows. At 9:31, this user is trying to access, one of the user from this set of 15 users is trying to access the EMP table. Now whether he needs to get the information from disk or whether he needs to get the information from the SGA of node 2, which is dev 2. Can you guess from where it needs to access the data? Whether it needs to fetch the information from the disk or whether it needs to fetch the information from SGA of node 2, which is dev 2 server. Okay, first you have to ask me the question like whether I did the commit or not. Say for example, I haven't committed the information yet. In that case, it needs to get the information from the shared storage or from the SGA of dev2. The first case is the user hasn't committed yet. Okay. If the user did not commit it, then it needs to fetch the information from the shared storage. That is correct. Then if the user has committed, then it needs to fetch the information from SG of dev2. How the blocks will be transferred from dev2 to dev1? How the blocks will be transferred from dev2 to dev1? It will be transferred over the network. The Ethernet 1 interface, which is connecting both the servers dev1 and dev2, using that Ethernet interface, this server will access the server 2 and fetch the content or fetch the blocks from the buffer cache, and it will store it in the local buffer cache of dev1. After storing it in the local buffer cache of dev1, it will give it back to the user. Now, whether we need to have a fast Ethernet card or a slow Ethernet card here. Before going to that, what is the need for SGA? What is the need for SGA? Why do we require SGA? Why don't we access the disk to fetch our information? To avoid the physical input output, we will access the information from SGA. That means the frequently accessed objects will be present in the memory, and whenever the user is trying to access those objects, it will be fetched from the memory, which will avoid the physical input output. And you already know the disks are slower when compared to RAM. So using that concept, Oracle build up this instance logic. Now the same thing applies whenever it is transferring the blocks from node 2 to node 1. If you have a slower Ethernet interface, then database performance will impact, because the whole concept of SGA or instance will be wasted if you have a slower Ethernet card. So one of the requirement, whatever the Ethernet card or whatever the Ethernet interface we are using, in order to connect each and every node in the rack cluster, that Ethernet interface should be faster. So whenever we are building a rack cluster, you need to make sure the Ethernet interface you are using to communicate between the nodes of the cluster is faster. So probably it will be using an optical fiber network with 100 gig or maybe more than that. Okay, that is one of the criteria. Next, how the blocks will be transferred, how it will request from node 1 to node 2, and how both these databases can access the same set of disks. This can be done using the cluster software. The main concept of cluster software is nothing but, for the end user, even though physically there are multiple servers which are accessing the database, from the end user perspective, it will just give an illusion, it will just make an illusion for the end user that only one server is serving its request, but he doesn't know to which server he is connected to. He'll just give one of the name. It may redirect, it may route the user to either dev2 or dev1. So all the things will be taken care by clusterware. So first, the cluster is nothing but a group of individual servers, group of independent servers act together to serve the request coming from the user, is nothing but a cluster. Now, to provide or to implement the cluster feature, Oracle introduced a software called as clusterware software. So to have this kind of setup, first we need to install clusterware. Before creating the database, we need to install clusterware software. In 10G, we have clusterware software and we have RDBMS software. Okay, clusterware. To build the rack environment, we need to install the clusterware. This clusterware software will be used to build a cluster. Now, RDBMS software will be used to create a database. But in 11G, we have grid infrastructure software, which is a combination of ASM plus clusterware software. So whenever we're trying to build a rack setup, in 11G we need to install the grid infrastructure in the first place before installing RDBMS software. In 10G we'll be installing clusterware software. Okay, this is one of the difference between 10G and 11G. In 11G we'll be installing grid infrastructure, which is a combination of ASM and clusterware software. So whenever we install the grid infrastructure software, we are actually installing the clusterware, as well as we can also configure ASM using the same set of binaries. And then using RDBMS binaries, we will create the database. But here in 10G, using RDBMS software, we'll create the database as well as ASM. Did I show you how to set up ASM on 10G? I guess I showed you and also showed you the difference, right? No? Okay, okay. So whenever we have to probably have to look at the video. I remember I told you about 10G setup on ASM also. Okay, I'll cross check it again. But whenever we want to configure ASM on 10G, we'll be using the RDBMS software itself. We don't need to install any other software to configure the ASM on 10G. But in 11G, we need to install grid infrastructure software to configure the ASM. And you already know how to install this grid infrastructure software and how to configure the ASM. But it is slightly different for cluster. We did it for standalone. In cluster, it is slightly different. Okay. Now, coming to the rack setup again. You'll have a registry called as OCR, which stands for Oracle Cluster Registry. Okay, Oracle Cluster Registry, and the another one is voting disk, VD, which stands for voting disk. I'll tell you what is the functionality of each and every component of this rack cluster. The first component is Oracle Cluster Registry. Do you remember when we configured the grid infrastructure software for ASM? It was trying to create OLR file in /etc/Oracle. In /etc/Oracle, it was creating OLR file. Am I correct or not? Okay. So what is that file actually? So whenever on ASM, whenever you do crs_stat-t, it is showing up the resources, right? Like .ons, .diskmon, and .csst. These are the three cluster resources. Whenever you do crs_stat-t, these resources will be showed up in the cluster stack, and after configuring the ASM, you'll have another cluster resource called as ora.asm. We'll also have ora.dg.diskgroup name, if you have a number of disk groups, you'll have a number of disk group resources inside the cluster. And apart from that, you'll also have the listener, and you'll also have the database. So whenever you're trying to reboot the server, automatically all these services or all the resources will be up and running. How they are up and running? So whenever the server is whenever you are starting the server, there is a file called as /etc/init tab. It is similar to services in Windows, or you can also make it as startup programs. If I do msconfig in Windows, if I go for startup, I can select the services which I want to start. Whenever I'm starting my Windows laptop, I want to specify the applications which needs to be automatically up and running. So some of those applications will go to meeting and Dropbox. So whenever I restart my laptop, automatically I can see an icon of Dropbox as well as an icon for GoToMeeting. In a similar way, if we want all these resources up and running whenever we start the server, we will configure an entry in /etc/init tab. So whenever we install the grid infrastructure software, it will add an entry in etc init tab, which will span or which will start all the resources, all these resources. But how? So the process which we add, or the process which got added to /etc/init tab as part of grid infrastructure software installation, it will access a file called as OLR file. This file will have the information about the resources which are registered in the cluster. By looking at the resources which are registered in the cluster, or by looking at the entries which are present in this file, high availability service daemon automatically brings up CSSD, ONS, diskmon, and then ASM and database. Okay, so this is a registry file which will have the information about the resources which are registered into the cluster. In a similar way, in rack we will have several resources. Apart from these resources, we'll also have several resources like instance name, because so here these are two physically independent servers. Now we'll have the same set of resources on node 1, which is dev 1. We'll also have same set of resources on dev 2. That means we'll have CSSD, ONS, diskmon, ASM. ASM means ASM instance. We'll have an ASM instance. We'll also have the disk groups mounted on, because the disk groups are shared across node 1 and node 2. And then we'll also have an instance running on node 1 and node 2. That means apart from database, we'll have dev 1 and dev 2. Now, whenever the cluster comes up, whenever the servers are coming up, it needs to access a registry file in order to bring up all the resources. Now, node 1 has some set of resources and node 2 has some set of resources. And if node 1 goes down, whatever the resources which are running on node 1 needs to be failed over to node 2. Because as I said, if something goes wrong on node 1, all the users will be connected to node 2, and the users will be the node 2 will be serving the request for all the users. So that means node 1 should know the information about what are the resources which are present in node 2 as well as node 1. That means this registry file needs to be shared across node 1 and node 2, because registry file have all the information about the resources which are registered into the cluster. Okay, the first thing is registry file is nothing but OCR. In rack we'll have an OCR file which is called as Oracle cluster registry file. Now this registry file will have the information about all the resources which are registered into the cluster. That means ONS of node 1, which is dev 1, ONS of dev 2, disk 1 of dev 1, disk 1 of dev 2, CSSD of dev 1 and CSSD of dev 2. All the resources of node 1 and node 2 will be present in OCR file, and this file needs to be accessed by dev 1 server as well as dev 2 server in order to bring up the resources. So as it needs to be accessed by dev 1 and dev 2, we will create this OCR file in the shared storage. Okay. Next thing is voting disk. Now, the cluster software needs to know which of the nodes are up and running. If one of the node goes down, all the resources needs to be failed over to node 2, and it needs to serve all the requests coming from the users. That means the cluster software needs to be continuously monitoring the health of the servers which are involved in the cluster. If cluster software is not monitoring the health of each and every server, it doesn't know which server went down, and it will not be in a position to fail over all the services from one node to another node. That means it needs to monitor the health of each and every node which are present in the cluster. In order to monitor the health of each and every node, it will make use of voting disk. So cluster software makes sure each and every node will poll the voting disk. That means each and every server will just touch the voting disk. For each and every second, each node in the cluster will be touching the voting disk. Whenever a node is unable to touch the voting disk, then rack will wait for 1 or 2 seconds. If the node is unable to touch the voting disk, then it will know the node is down, and it will fail over all the resources or all the connections which are connected to the node 1 to node 2. In order to monitor the health of each and every node, rack will make use of voting disk, and voting disk will be used by each and every node in the cluster to poll the health of its own node. Okay, so each and every node in the cluster will poll the voting disk saying that it is healthy. If it is not healthy, it will not be in a position to poll the voting disk. Any questions till now? Okay. Now, this voting disk needs to be accessed by each and every node, right? Because all the nodes in the cluster, they should touch the voting disk to poll their health. So even the voting disk needs to be present in the shared location. Okay, that is the reason why I placed OCR and voting disk on the shared storage side. Apart from this OCR and voting disk, we will have the physical files of the database, which are data file, read log files, control files, arclog files, and SP file. Okay. Now, what kind of file system which we can use for this shared storage? What kind of file system we can use for this shared storage? We can use two types of file system here. One is ASM, second is raw file system. These two type file systems can be used to store the physical files of the database, which are data files, redo log files. Let me make it as log file. So LF, SP file, control file, and ARC files. So all these files can be on ASM or raw file system. You cannot use local file system for rack. You cannot store the database related to files in the local file system, because if you have the files in the local file system, it cannot be shared across both the nodes, because the local file system is nothing but it will have a logical volume manager which is specific to that node, and it will keep on writing the content into the disk, and it will just put a lock on that. Whenever you have a local file system, that operating system kernel will put a lock on the disk such that no other server can access the same disk. So that is the reason why we cannot have a local file system to place the data files, log files, SP file, control file. What we can use is ASM and raw file system. So most of the companies will prefer to use ASM because of the advantages which you already saw: striping and mirroring. And also, without the downtime, we can add additional storage to the existing disk groups whenever we require any space. Now, for voting disk and OCR disk in 10G, we can place OCR and voting disk in either OCFS file system. This is another file system developed by Oracle, which stands for Oracle Cluster File System. So using OCFS file system, we can place OCR and voting disk in the shared storage. In 11G or raw file system, you cannot store OCR and voting disk on the ASM, because in 10G ASM is part of RDBMS software, right? So cluster, to bring up the cluster, it needs to access the OCR and voting disk. Now if we have OCR and voting disk on the ASM, RDBMS software comes second, cluster software comes up first. So to bring up the cluster, it requires ASM if OCR and voting disk is part of the ASM. So to overcome that issue, that's the reason why we cannot place OCR and voting disk in ASM file system in 10G. But in 11G, as ASM is part of the clusterware, ASM plus clusterware is nothing but the grid infrastructure. So we can have OCR and voting disk either in OCFS, ASM or raw file system. But Oracle recommends to use to place OCR and voting disk in ASM. Even though we can place OCR and voting disk on OCFS or raw file system in 11G, Oracle recommends to use ASM. So even in our setup, we'll be using the ASM file system in order to place OCR and voting disk. Do you understand why in 10G we cannot have OCR and voting disk in ASM? Okay. Say for example, in 10G, we need to install the clusterware software. Then we need to install the RDBMS software. RDBMS software gives us ASM as well as database. Now, this clusterware needs to be up and running. Clusterware is nothing but the CSSD, CRSD, ONS. So these are the things which you know till now. So let us take this as an example. Now these are the cluster processes which are part of clusterware. Now whenever the server comes up, first it will bring up the clusterware. After that it will bring up the ASM, and then it will bring up the database, which already saw in the standalone. Whenever we brought up CRS underscore start hyphen all, first it will bring up the CSSD, then ONS, diskmon, database, ASM, listener, and then the database. So that is the flow in which it will bring up each and every resource. Now in 10G, if we place OCR and voting disk in ASM, now to bring up the cluster, CSSD, CRSD and ONS will make use of OCR and voting disk. Now If we place OCR routing disk in ASM, without starting up the ASM, how can it access OCR and routing disk? If the disk groups are not available, how can it access OCR and routing disk? That is the reason why we cannot place OCR and routing disk in ASM. But in 11G, we can place OCR and routing disk in the ASM file system. That too 11G R2. In 10G R1 and 10G 11G R1, we can place OCR and routing disk in OCFS file system itself. We cannot place it in ASM. Any questions till now?
No.
Hello? No questions? Okay. So next, as I said, we require Ethernet 1 in order to communicate with the nodes which are present in the cluster. Till now, we just added one Ethernet card which is ETH0. Correct or not? ETH0. Whenever we are trying to create a server on virtual machine, we just added an Ethernet card called as Ethernet ETH0. But whenever we're building a server for rack cluster, we will add two Ethernet cards. One is Ethernet 0, the second will be Ethernet 1. Ethernet 0 will be used for public. Even in standalone, it is used for the public. Public in the sense, users outside the server can connect to the database using this Ethernet card. So whenever you are trying to connect to the database, you are providing the IP address. So that IP address is nothing but the IP address is running on Ethernet 0. So Ethernet 0 is be used by the users in order to connect to the database. And that is the reason why it is called as public, because it is accessible to each and every user who are present in the company network. Now the second one is the Ethernet 1, which is called as private. This private interface will be used for the communication between node 1 and node 2. Or else if you have 4 nodes, dev 1, 2, 3 and 4 in the cluster, all accessing the same set of shared storage, those for communicating among dev 1 to dev 2, dev 2 to dev 3 and dev 3 to dev 4 will be using this private Ethernet. Only the nodes which are present in the cluster can communicate each other over this network. Other users cannot connect to this network. That is the reason why it is called as private. It is private to the cluster itself. Rest of the users cannot access this Ethernet card or this Ethernet interface. I'll show you how we can configure a private Ethernet interface and how we can configure public Ethernet interface when we are doing the setup. But for now, just you need to know that Ethernet 1 is called as a private interface, which will be used for communication between the nodes which are present in the cluster. And the public interface will be used by the users in order to connect to the database. So whenever we are building a rack server, first we have to create two servers, dev1 and dev2. Like the way we created the test server, we'll just create two servers, dev1 and dev2. And in dev1, we'll allocate 40 GB to install our RDBMS software as well as to install our grid software. Even in dev2, we'll add a 40 GB hard disk to install RDBMS software and grid software. After that, we will add two Ethernet cards, Ethernet 0 and Ethernet 1 on dev1 as well as dev2. Then in 11G R2, I'll be showing you the 11G R2 rack setup, and in 11G R2, each and every server requires at least 2.5 GB of RAM allocated. So if your laptop has 8 GB of RAM, then you can practice this rack setup. If you don't have 8 GB of RAM, I'll be showing you the 10G rack setup, which we can which you can practice. For 10G rack setup, you require 1.5 GB RAM for each and every server. But for 11G R2, you require 2.5 GB. So after adding these Ethernet cards, we'll be allocating 2.5 GB of RAM for Dev 1 as well as for Dev 2. After that, we'll be creating a shared storage with 6 disks. Among these 6 disks, 2 will be used for OCR and routing disk. 4 disks will be used to create 2 disk groups, DG1 and DG2. In order to store the data files, read log files, control files and arclog files. Okay. Actually, I have office work now. Just now I got a call, so I have to wind up the class. I'll continue tomorrow. Is that okay? I'll continue tomorrow again at 7 p.m. CST. Sorry, guys. Okay. I'm not sure whether you download it or not. I'll also send you. I'll share a Dropbox folder with you guys. So when you go onto the Dropbox, just click on the softwares folder and then Vivek, do you remember the location for prod1.rar and prod2.rar? Is it rack? Okay, yeah. Okay, I got it. Okay, so when you click on the softwares folder, you'll have a folder called as rack. Inside rack, you'll have 3 files. One is prod.rar, second is prod2.rar, and third is shared storage.rar. So make sure you download these rar files, and then I'll continue tomorrow. Okay. Yes, I'll share the folder with you also.
Is
Okay.
it for 11G or
Yes, I'll share the folder with you also. Okay.
is it for 11G or 12? I mean 10G.
It is for 11G. It is for 11G.
Okay.
Probably in the weekend I'll show you the 10G setup. Okay, you'll be getting the request to join the Dropbox folder. Just join into the Dropbox folder and download these 3 rar files, and then I'll continue tomorrow. Okay, then bye. Good night.